Modularity refers to the idea of putting together a large system by developing a number of distinct components. That means you have individual components. What I will do with this, all these I'll put it together to build a large system. Putting different components into one to get a large system is known as modularity. So before that, these components will run independently. It will finish the job. I have assigned the job, it will finish. Once it completes the job, now I will integrate. And then integrating these to provide the required functionality. I have a big job to be done, that I will divide it among the distinct components. Each of these component will complete the job. It will run independently when the job is assigned. So once they complete, now I will integrate to complete the required functionality. That becomes a large system. That is called modular design. This approach is easier to understand than one that is designed as a monolithic structure. So instead of doing the complete job with a one model, with a only one monolithic means a single structure, what I have done, I have divided a job into distinct components. Do it independently. Once you complete, then you integrate as a large system. That is called as modular design. What is there in the next step? The system's functionality must be provided by well-designed cooperating modules. That means, how is it you are performing the system functionality? You are designing. The design is very well done and cooperative models, because I have given the job to different individual models. So these models are to be cooperated. They have to work together. Fine. So this is to be done. Then we can achieve the good results. We can build a large system with the help of different components. That is called as modular design. So each module must perform functionality. No one can sit simply. Everyone should participate here. So each module will perform the given functionality. Equally they participate. That is clearly specified by an interface. So who is going to provide an interface? Parent class we have instantiated into subclass. Now the same concept here. So interface is done. So this subclass, instead of subclass I am using the term distinct components here. So this will complete the job. So each and every module will complete the given job. The interface also defines how other components may interact or communicate with the module. So interface not only assigns the job, not only gets the work done, it also see to that whether these modules will interact with each other. Because sometimes I may need the output of the previous component to the next one, for the next level. So that I should see to that whether these interaction is done or not, whether the output is given as input to the next stage or not. That is also taken care by the interface. We would like that a module clearly specify what it does, but not expose its implementation. You need to give just the information about, you are going to define what actually I am going to perform. But the complete implementation is invisible. But the outside world will not give the complete implementation part. This separation of concerns gives rise to the notion of the encapsulation. This results in the notion of encapsulation. Notion means what here? It means the amount of encapsulation is increasing here. Okay? So I need to go for larger software, so more number of components are encapsulated here. In place of objects, I will use the term components here. So what are the things we discussed under modular design? Modular design is nothing but putting these distinct components together as a large system. So assign the job, get it done. These components will run independently. Once they complete the job, integrate these components so that the required functionality is completed. Okay. So this approach is easy to understand than a monolithic structure. Such a design is known as a modular design. And here the system's functionality must be provided by well designed. You should design properly. You should assign the job properly to all the components so that no one should sit idle. So these models should cooperate with each other. They should work together. Then the interface specifies which model has to perform which job, and interface also defines how these components have to interact with each other. And would like to that a model clearly specify what it does. Model should define what operation it is going to do, but not the complete implementation part. So this separation is resulting with the notion of encapsulation. You go for more amount of encapsulation. So we are going to build a large complex. Encapsulation means what? That the module hides details of its implementation from external agents. That's what the clients will not know the complete implementation part. They just know what operation is done, just know the definition, but not the complete implementation part. Implementation part is hidden by from the clients. So how is that encapsulation done? For example, we go for abstract data type. In general, we use the data types such as integers and characters. The programmer specifies the collection of operations on the data type and the data structures that are needed for data storage. That's what the programmer, the designer will specify. These are the set of operations I am going to perform on which data type the programmer has to decide, and the data structures. What are the different data structure I need to go for, and what are the type of the data, the amount of data I am storing. This is data type. This is the value of the data type. Next we have users of ADT perform the operations without concerning themselves with the implementation. That's what ADT means, abstract data type, perform this operation without concerning themselves with the implementation. They are not worried about the implementation part. They do whatever the operation is asked to do, that is performed. They are not worried about the complete algorithm.